Okay, good morning, everyone. Okay, can you hear me? Can you hear me, yes or no?
Yes.
Okay, good. I had difficulty with the other class, so I want to make sure I didn't have any problem with you. All right, so we start with your questions. How did the homework go? Which questions do you have from the homework? Okay. Please put them on chat. Anyone? Number 36, Alex, okay, which 36, let me have a look at it. Okay, another question. All right, so we go through your problems, definitely. And my first question to you is the following basic questions. What's the main conversion between region, between region and degree? Quickly.
It's pi over 180 or 80 or 180 over pi.
Between degrees and region. Okay, so you meant 1 degree is how much? Repeat.
Pi over 180.
Right, region. And 1 region is?
180 over pi.
Yes. And the way I memorize it is this one. Okay, pi region is 180. Right, and so to be able to answer question 36, 39, we have definitely to remember the following. If you have a circle of radius r, any circle of radius r, and you have an angle, so this is my radius, that's my radius, and you cut off a little piece like this, and this is angle theta in region. Okay, so what's the length of this arc? Quickly remember the formula. It's a formula we have to remember, honestly, there is not much. What's the length of this arc?
2 pi r.
Oh,
Formula.
no.
S equals theta of r.
Right, it's r times theta. 2 pi r will give you the circumference of the whole circle. Now, if you're only interested in the arc, which is cut off by the angle theta, it's r times theta. Okay? All right. With this in mind, we're going to look at both your questions, 36 and 39. So 36 is, what is the length of an arc that is cut off by an angle of 225 degrees in a circle of radius 4 feet? So what they are talking about means you have a circle and the radius is 4 feet. Okay, that's the rest of my circle. And inside the circle, we cut off an arc of angle 225. So what I mean by this, we start here, we go around an angle of 225. So by now we should know that 225 should be, I think, somewhere in here. And this is my angle, 225. And this is the arc they're talking about. So this is 4 feet, that's my radius, and this is the arc they are talking about. Okay. So imagine yourself, basically imagine the following story. You have a circle of radius 4 feet and you are walking. You are walking along this arc and you keep walking. Okay, so that the angle that you form is 125. The question is, how much did you walk? Okay. Ideas, answers, whatever. So how much did you walk? So you have a circle, you keep walking, 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 making, basically you walk 3/4 of a circle. So how much did you guys walk?
Would it be 15.7 feet?
Well, you know, I like how you did it, and then I want the answers. First, how did you do it? That's a crucial part for me.
So since to find arc length is S r theta, I found theta by having the angle 225
Mhm.
times that to pi over 180, which gave
Right.
me
Okay, so the first step you have to do is to convert 225 to radian. She's absolutely correct. The formula works if your angle is in radian. So step number 1, that's what she's trying to tell us. So step 1, because the angle is not given in radian, convert 225 degrees to radian. That's exactly what she's going to tell us, right?
Mhm.
So this is going to be 4 times, I want theta in radian. So how did you do it in radian? Keep going.
So multiplying 225 times pi over 180, it gave me 3.926.
So that's her conversion. So it's 225 times pi over 180. Okay? She's absolutely correct. And then she basically computed that. And how much did you get?
3.926.
3.926.
26.
I'm going to trust you. So this is going to be 4 times 3.926. And the unit is, what's the unit?
Feet.
Feet. Because the radius is in feet, it means the length of the arc will have to be in feet as well. And now she just multiplied. I can do it in my head. I don't feel like it. So it's 3.926 times 4, and I'm getting 15.704. She's absolutely correct. Okay. Any questions? Now, 225, is it a special angle? Is 225 a special angle? Back to you. What do you think? Is 225 a special angle? No? Anybody? How many 45 is there in 225? Because an angle I think you should know.
There's 5.
5, yes. So it's nice to know that 225 is 5 times 45. It means it's basically 5 times pi over 4. So 225 is one of those angles that we should know that it's 5 times pi over 4. I mean, of course, everything we did is fine, but I also would like to point out that 225 is 5 pi over 4 because 225 is actually 545. So that's another one of those special angles that I would like you to know. Okay, so pi over 4, 45, and then you have 3 pi over 4, 135, 5 pi over 4 is the 225. Okay, so this is an angle that I think is good for us to do. All right, so now let's look at the other question you guys asked about the same topic, number 39. All right. So number 39 is along the same line, I think. So I will draw the picture from the book. So we have that, and they go up to here, and then they go dash. That's the picture they have. And they put a point P. So verbatim the picture. They call this S equal to 3. And they put 5 here. and they put the angle theta. Okay, and in this question, the question is the following. Where possible, give the radius, the angle, and the length, and the coordinate of the point P. So what they want is the following. They want the radius, the angle, they want S, the length, and they want the coordinate of the point P. Every aspect you have. Is that clear? So we start one by one and we answer those questions. Okay. So let me start. Okay, what is the radius? Please put your camera on. Those who don't have it, please put it on. Okay, I have one message. Okay, the radius is 5. Do you agree with your classmate? But if you look at the picture, that's the radius from here to here. That's really the radius. Correct. What is theta? Back to you guys. And they definitely didn't give us theta. They gave us R. They didn't really give us theta. Can we find theta? Did they give us enough? Okay, Rebecca, keep going. Tell me theta. And tell me the work. Okay, anybody? You guys tell me yes, yes, yes. It's 3/5. You're absolutely correct. Tell me what you did. So we don't have theta, but we have the arc length. We have S. So what she said, okay, we have S equal to 3. But S is R times theta. I know S. I know R. I can find theta. The theta is 3/5. And what is the unit here? Crucial. What is the unit? The formula gives us the unit in what? Radian or degrees? Back to you. Back to you. Radian or degrees, we get the unit. This unit here is in radian. It means the angle is 3/5 or 0.6 radian. So the formula will give us the angle in radian. So this is 3/5 radian or 0.6 radian. And that's really the explanation for that. My S is my S. My S is equal to 3. Is that clear? So it's 0.6 radian. So if 1 radian is almost 57 degrees, so this should be a little bit less than 30, like 25 degrees. So that's to give us an idea. So, but remember the formula gives us the angle in radian, not degrees. Very good. Finally, we want the coordinate of the point P. What are the coordinates of the point P? So now this is really the picture. The picture is here. I will draw the picture. So basically now I have a circle. That's my circle, kind of, accepted. And I have, this is 5. I have an angle. And an angle here is 0.6 radian. And I have a point P here. And they want me to find the X and Y coordinate. That's really my picture. How do we find the X and Y coordinate of this point? You guys remember, because important.
You have to take the sine and cosine of the angle theta. But I did have a question. Did you want us to leave the angle theta in radians, or did you prefer to leave it as a degree?
You can keep it in radian.
Okay.
No problem. But when you use your calculator, what are you supposed to do? Are you with me? You have to put it in radian mode.
Right.
Okay. All right. But there is one mistake in your answer. What do you think the mistake is? So for you, the P, let me see what you said, and then we have to fix the mistake because it's fairly common. So what's the X coordinate of the point P? And what's the Y coordinate? repeat what you told me because I have to fix it for the whole class, almost. The x coordinate is?
X coordinate is the cosine of point P, or the angle theta, which is 6 radian. And
If
like
you are correct, if we are on the unit circle.
right.
We're not on the unit circle.
Mm-hmm.
We are
So
on
you
the
have to
circle
multiply
of
by
radius.
5.
Yes.
Mm-hmm.
Very careful. You multiply it by 5.
Right.
Right. So if we are not on the unit circle anymore, it means if we have here, that's the picture. If we have the radius r, everything get basically stretched by r. And I have in point theta, that's not the unit circle. So this is going to be r cosine theta, r sine theta. On the unit circle is sine cosine. It's not the unit circle, everything is stretched by a factor of r, whatever this is. So it's 5 cosine 0.6, 5. So it means this coordinate here. So it means this from here to here. So this is 5 cosine 0.6. That's really what it is. And this is 5 sine pi over 6.
I have that written down. I just I was just giving the basic answer.
That's okay. You know what? I don't know even your name. So don't worry about anything. My goal is that you guys pay attention because it's a fairly common mistake, you know, to forget the 5, rightfully so. All right, so now let us find them up to 3 decimal places in this particular problem. Just I want to make sure everybody put your calculator in radian mode. I want everybody to know how to put in radian mode. Do you guys remember how I told you? If I keep 0.6, I have to stay in radian mode. So you turn it on and you go to mode. That's on my calculator. So you go to mode and you go all the way to radian versus degree. So in my case, I want the radian. So I keep radian. Okay. So now my calculator is in radian mode. Otherwise, you will have nonsensical answers if we don't do that. And now I need 5 cosine pi over 6. So it's 5. Where my cosine? Cosine. Either you put 5, 6, or you put 0.6. It doesn't really matter. So 5, 6. I get 3.362. So that's the x coordinate. So the point P is 3.362. And what do you guess? Compute the y coordinate for me. Every one of you use your calculator in radian mode just to practice the radian mode. And see what you get. Okay. How much did you guys get? Anybody else? Oh, okay. I think I entered the wrong number somehow. It's 3/5, right? Okay. I think I got this wrong because I'm looking at my calculator and for some reason I entered the 5, 6 instead of entering 0.6. Okay, so it's 5 cosine 3/5. Okay, this one was wrong. You guys should have corrected me. This is 4.12. 1 to 6. Okay. Very good. All right, we still have one problem. You guys ask number 43. So all your questions are along the same line. Number 43. Okay, and it's the same picture. So we have something like that. And we stop, then it's dashed. So this is 80 here. And we have, so that's my point P. And here are the pieces. They're giving me theta equal 3 pi over 7. When they don't put unit, it means radian immediately. And now their question is everything. R, theta, the length, which is from here to here, and the coordinate of the point P. Okay, all right, so let's go through that. We can go through that much quicker. So what's the radius? And I think I'm gonna start asking student, and I believe me, I pick you very arbitrarily. Caleb, are you with me? Caleb, are you with me? Okay, Giselle. Giselle.
It's 80.
80. Theta. Quickly. Giselle, stay with me.
The 3 pi over 7.
The length. What's the formula for the length?
It's the
Radius
times the theta.
times theta. Okay. Do we have to do anything with theta in this problem?
No.
No, because
Already given.
in which unit? Theta should be given in radian. If it's not given in radian, then you have to convert. This problem is given in radian. When they don't tell you anything here, it means the unit is radian. So times 3 pi over 7. Okay, if it's in degree, you convert. It's in radian, the way you keep it. So now finally, what is S? Now you can pick up your calculator and compute those numbers. Times 3 pi and divided by 7. So I'm getting 107.711. And the unit, they don't give us a unit, so whatever. If it's inches for the radius, the length is in inches as well. Okay, now finally, what's the coordinate of the point P? So at this stage, I'm viewing the point P here as a point on the circle of radius 80. That's my point. And what are the coordinates? Okay, so what's the coordinate of the point P? So what's the x coordinate? Giselle, would you like to stay with us?
I was having trouble with that one.
Okay, let's remember the formula. It's the radius times cosine of the angle. The radius, the sine of the angle. But that's what the cosine and sine. It means that if you take this point, the x coordinate here is whatever the radius is of the circle, you times it with the cosine. And the p, whatever the radius, you times it with the sine. Okay, that's what the y coordinate and the x coordinate. That's the definition of sine and cosine. So the x coordinate will be, my radius is 80. My angle is 3 pi over 7. Everything is in radian. Our calculator is already in radian mode, so it's going to be 80, and it's going to give me the cosine of 3 pi over 7. How much you guys are getting? Because I seem to be goofing. How much you guys are getting?
17.8.
17.801.
Yeah.
Anybody got the same thing? I guess so. Please, I want all of you. And what did you get for the second one?
77.9.
Right, 77.994. Yeah, That's the answer. Be careful, you have to be in radian mode. Be careful in radian mode. So if you don't get that, it means you don't have your answer you don't have the calculator in radian mode, because that's what we are using for the angle. Okay. Now, let us say a student is doing this problem and they got the x coordinate to be, I don't know, 83. Should the student know immediately that he's wrong? I'm asking everybody. Suppose you're doing the math, you might stop, you got x equal 83. How the student should know immediately that his answer or her answer is not the correct answer?
His y value is longer than his x value.
The y, okay, I'm gonna switch it. Suppose the y is 83. How would you know the answer is wrong?
It's bigger than the radius.
It's bigger than the radius, absolutely. The maximum value has to be 80. So we cannot have a value bigger than 80. The maximum value of the x coordinate has to be 80. So if you get anything above 80, you're doing it wrong. Okay, that's, you have to be careful. So even the answers should be at least make sense a little bit. All right. So my point P will have for coordinate 17.8. It means in your picture here, that's the 17.8. That's what is in the picture. And the x coordinate is 77.994. Means in your picture, this is the 77.994. Okay. Any questions before we move on?
No.
All right. Now, let me review one last thing before we move on to the section that follows. I'm going to ask you questions and I want answers. So my question now is something I did last time, but I want to make sure every one of us is following. So my question is, use the idea of reference angle. So use the idea of reference angle. That's the worksheet I worked on it last time. Use reference angle and the symmetry of the unit circle of unit circle to find the, and now I'm going to write it in red, exact value. Exact value of the sine and cosine of the following angle. Of the following angle. And what you can use, the only thing you can use is the following. So those are the basic angles that usually I force my student to memorize. Now I cannot control that because you guys are online. Usually my student totally memorize this, period. I usually don't give them a break for that. 0, pi over 6, pi over 4, pi over 3, pi over 2. It means 0, 30, 45, 60, 90. Total memory. All right, let's see how well you guys are doing. What's the sign of 0? Without looking at any document, anything. Can you tell me what the sign of 0 is? Always the unit circle. We never move away from it. What's the sign of 0? 0 is here, 0. The cosine is the x coordinate, which is 1. Now pi over 6. Do you guys remember pi over 6 without looking? The exact value. The sine is a half. That's the exact value. Square root of 3 over 2. So if I'm asking you about the exact value of cosine pi over 6, I expect square root of 3 over 2. I don't expect the values that you pick up from your calculator. Pi over 4 is this. That's the only thing you have to remember. Then to switch. This is a half. This is square root of 3 over 2. If you memorize those, you actually know a lot. Pi over 2, you go back. That's pi over 2. The sine is the y coordinate. The cosine is the x coordinate. All right. So using this, the idea of reference, and the symmetry of the unit circle, I want you to find the following for me. The sine and the cosine of theta equal 2 pi over 3, let us say. I want the exact value. It means I don't want the answer from the calculator. I want the exact value. All right, I give you a minute to figure it out. Always my unit circle. So you always start by drawing this stuff. It's my unit circle. And then you draw 2 pi over 3. Now 2 pi over 3 is how much? Quickly, how much? It's 120 because pi over 3 is 60. You're done. So 120. So 120 should be here. Okay. And basically, so that's my unit circle is crucial. And I want the sine and the cosine. All right, we did that last time. So I will remind you, the first step is to draw the reference angle in the first quadrant. What is the reference angle of 2 pi over 3? What's the reference angle? Remember, the reference angle is the angle between the terminal side and the x-axis. The terminal side and the x, that's the terminal angle. That's the reference. So the reference angle is 60. Okay, so first you find the reference angle and then you draw it in the first quadrant. So reference angle, it means the symmetry to that. That's 60. Okay, so that's really what we did last time. And now I want you to find the sine and cosine using the symmetry. 60. What are the sine and cosine? Once you know this table, you're done. The x coordinate is the cosine, which is the half. And the y coordinate is
You have your sine and cosine the same. It's supposed to be root 3 over 2.
My goodness, what did I do here?
And 1/2 on the
Oh
bottom.
my
Yep.
goodness. Thank you very much. Okay, so this is a half and this is the square root of 3 over 2. Oh no, now I want those. So what's the cosine of 2 pi over 3? Total symmetry. And what's the sine of 2 pi over 3? I want the exact, it means, I know you can pull this calculator. When I mean exact, I mean I want the square root of 3 basically somewhere. All right, quickly, what it is. We've done this last time, as I want this to be very clear in your mind.
The cosine would be negative 1/2.
The negative 1/2, exactly, because symmetry, this is a half, this is the minus, total symmetry. And the sine, you're right.
It would be square root of 3 over 2 still.
It will be square root of 3, total symmetry between them. Okay, I'm gonna give you 2 more along those lines, but this time I'm gonna pick a student on an arbitrary way. So the same type of pictures, the same thing. So I'm gonna keep those in front of us and I'm gonna take theta to be 5 pi over 3. And the process is, you draw your angle, find the reference, draw it in the first quadrant, then use the symmetry to find the sine and cosine of 5 pi over 3. But this time I want to give you time. I want to give you a whole minute for it. Are you guys ready? So I'm gonna pick a student, Lucas P. Are you with me?
Yeah.
Okay. Okay. Tell me what you got so far.
I didn't get all the way through it, but
That's
I
okay.
got to 5 pi over 3, which is 300 degrees.
300. So it should be here, right?
Yeah.
Okay.
And then I did 300 minus 360, which is 60 degrees, so I can get the reference angle.
So reference angle is 60. So far, we're doing great. So reference is 60. Where do you draw it when you do it?
I'm sorry.
You draw it in the first quadrant.
Oh no, I didn't get that part. I just got this the 60 degrees, and at that point, I didn't get that far.
All right, stay with me then. I draw it in the first quadrant. All right. All right. So this is 60 or pi over 3. Okay, what are the coordinates of this point? This is the unit circle. It means this point, its coordinates are, who would like to pick up? And he can say with us. What are the coordinates of this point?
It's 1/2 and the square root of 3 over 2.
Is she right? Of course she is. So the cosine of 60 is 1/2. That's the cosine. That's where you use this table from. And this is the square root of 3 over 2. Now why this is extremely helpful? Do I know what, this is my angle. That's the 5 pi over 3. Its sine is the x coordinate of this point. Its cosine is the y coordinate of this point. So, are you with us? Okay. All right, answers now. What is going to be the cosine of 2 pi over 3? And what's going to be the sine of 2 pi over 3?
The cosine would be 1/2 and the sine would be
1/2.
negative square root of 3
the
over
x
2.
coordinate of this point. And the sine?
Negative square root of 3 over
Negative
2.
square root of 3 over 2. So the cosine is 1/2 negative square root of 3 over 2. Okay. My last question is the following. So last question. I'm going to draw a circle. I'm going to draw a circle. This is problem number, I don't know, like 30 in your book. Actually, I was planning to do 25 and 30. So number 25. I will set up the problem and we're going to do it. So number 25, the question is find the exact value for the coordinate of the point W. So I draw the point W. It's my point W. And R is equal to 10. And my point W is here, right in the middle. It means this is, no, sorry, not here, to 10. So this is to 10. And the question is, they want the exact coordinate of W. When they say exact, it means they want like square root of 3 over 2 to be part of it. So they don't want you to pick up basically your calculator. They want actually you to go through the process we did in a minute ago. So the question is, find the coordinate of the point W. Right, I give you, again, I'm going to give you some times because I really want you to kind of think about it a little bit, and then I'll take you from there. Shall we start? Okay, yes, all right, so let me pick one and the student. So Samantha, are you with us?
Yeah.
Yeah, go for it. First, what's the x coordinate? What's the formula for it?
The formula?
Yeah, before we start doing the computation. So that's the point. When a circle of radius r, that's the angle.
I don't really remember the formula because this problem really gets me every time. I tried doing it on the homework, but I couldn't understand it.
No, that's why I did it. It's the radius times cosine of the angle. The y is the radius, the sine of the angle. Okay? Are you with me?
Yeah.
That's the formula. So it's r cosine theta. So if you are on a circle of radius r, if you are on a circle of radius r, if you are on a circle in general of radius r, one of the cosine and sine, we can evaluate them, of course, using a calculator, and what we've been doing right now. If you have any, so this is circle r, and you have a point on the circle, radius r, and you want to find what are the coordinate of this, the x and y coordinate. The x is r cosine theta, whatever this angle is. The y is r sine theta. So it's r cosine, r sine. That's the picture. So that's exactly what we're doing here. It's r cosine, r sine. Now the r in this problem is the radius. So the x coordinate is equal to 5 cosine to 10. And that's the 5 sine of 210. And 10 is in degrees, not in radian.
Wait, the radius is 5?
I'm at the 10, of course. I'm checking if you guys are following me or not. Thank you very much. All right, now, what is the exact value of cosine 210? And what's the exact value of sine 210? So that's the formula. Now I want to find cosine 210, exactly how much without using our calculator. Okay, because those are very special angles. So let us find cosine 210. The same way we've been doing it before. So a little bit, what's the cosine of 210? I'm just going to focus on that. So if I am on the unit circle, and this is 210. What's the cosine? Go after the reference, which is 30, because that's how far 210 is away from 180. So I'm going to draw 30 here. Now, what are the coordinates of this point? So here we're going to find the exact value of cosine to 10 and sine to 10. We're going to find the exact value of those and then substitute. So to find the exact value, we go to our unit circle. This is my angle to 10. The reference is 30 because that's how far away we are from the 180. And then, okay, I say, okay, what's the cosine of 30? The cosine of 30 is the square root of 3 over 2. And the sine is a half. And that's what you should know. So what's the sine and cosine of this one? So the cosine of 210, the exact value is, so this is square root of 3 over 2 is going to be the minus the square root of 3 over 2. And the sine of 210, if this is a half, it's going to be minus a half. So that's what I mean by the exact value. So finally, what's the x-coordinate of the point W? So the point W will have for coordinate 10 times the cosine of 210, which is minus the square root of 3 over 2. And sine of 210, it means 10 times minus a half. So its coordinate is going to be minus 5 square root of 3 minus 5. So this is here. That's the minus 5 halfway through. And this is the minus 5 square root of 3. So let me a little bit see what we did. We want the chord of the point W. W is a circle. The radius is r. The coordinate r. If this is the angle that formed, the x is 10 cosine of the angle, that's 10 sine of the angle. Now, since I want the exact value, I said, okay, what's the cosine of 210 and sine 210? What's the exact value of those? Now we go back to what we've been doing. Okay, to find, those are special angle. I draw the angle cosine 210. I find its reference. I draw it in the first quadrant. The benefit of that is that we know what's the cosine and sine of the special angle. The cosine of 30, square root of 3, and this is 1/2. And this will allow me to find the coordinate of this point, which is going to be minus and minus. The x-coordinate is the cosine, the y-coordinate is the sine. And then I multiply them by 5. Any questions? Okay, I'll do 30 because you guys are very reluctant with those problems. And number 30 is the following. Find the exact coordinate of the point at the given angle on a circle of radius 5. So I have a circle of radius 5. So that's a 5. And I have a point 225. So 225 should be here, somewhere in between. And this is my point W. Find the exact coordinate of the point W. And right here, I'm going to give you the special angle. Theta, cosine, and sine. 0, pi over 6, pi over 4, pi over 3, pi over 2. All right. And this is 225. So coordinate of the point W. Anybody feels comfortable?
Yeah, I'll take a shot at it.
Sure, go ahead.
So first I wanted to find the reference angle.
Mhm.
So I subtracted 180 from 225 and got 45 degrees. So I drew that in the first quadrant. And on a unit circle, the exact coordinates of 45, I believe, are square root of 3 over 2 and square root of 3 over 2.
No, it's square root of 2 over 2.
Oh, sorry.
Okay, yeah. I wish you guys can memorize those. I don't know. How can I make you memorize it? So that's the 225. So she's trying to find the cosine and sine. So she drew the reference angle here. The reference angle is 45 degrees because 225 is 45 units away from 180. So she took 225 minus 180, gave her the 45, which is this angle right there. So I am on the unit circle here. So this point on the unit circle has for coordinate, the cosine is the square root of 2 over 2, the square root of 2 over 2. So far, that's what she told me. Keep going.
So because we have a radius of 5, it would be radius times square root of 2 over 2 for both of them.
But which point you're talking about now? Let's be very precise.
Okay, well, I was still talking about the first one in the first quadrant because I hadn't flipped it back over.
Okay.
Unless you'd prefer me do that first and just talk about W.
Okay, so W has for coordinate 5.
Well, if we're talking W, then it would be
yes. Because I want to use the same formula. I don't want to confuse the student tremendously.
Okay.
You're fine. The way you're doing it is absolutely correct. No question.
Okay.
Okay, and the sine. So now, go ahead.
Oh, because we know the exact on a unit circle, we can just take that for W as well. And because it's in the third quadrant, it would be -5 square root of 2 over 2 for both points, or for both X and Y coordinate.
So we know that the cosine of 225 is minus the square root of 2 over 2. The sine of 225 is minus square root of 2 over 2. So it's going to be minus the square root of 2 over 2. 5, the sine is minus the square root of 2 over 2. So finally, the coordinates are -5 over 2, square root of 2, and minus 5 over 2, the square root of 2. No, they are definitely equal, which is not surprising because if you have a 45-degree angle here, means I have an isosceles triangle. It means this and this are basically equal in length to each other. So I'm not really surprised. So this is going to be the -5 square root of 2 over 2, and this is -5 the square root of 2 over 2. Okay, so the idea is the formula 5 cosine, 5 sine of the angle. And then we said, okay, can I find the exact value of those? So we went down to my unit circle. This is the angle 225, absolutely. The reference is 45. It means this point, square root of 2 over 2, square root of 2 over 2. So this point down here is the minus and the minus. This will give me the cosine of 225, I multiplied by 5, the sine, I multiplied by 5, and I am done. Okay. All right, so today my plan is hopefully to make those ideas clear. And next time we're gonna start by going back to sine and cosine and graphing them and shifting them up and down. So I'm not introducing anything new today. I want you to go back. I mean, you can take the quiz, of course, and see how well you guys will do. And then start to review this again, let it become part of you. And then next time we're gonna move on to the graph of sine, the graph of cosine, and our goal is at the end of next section is when I took this Ferris wheel at the beginning of the semester and we start graphing it, Now the question is, what's the formula that will fit? What's the formula that will fit the graph? And that's really what we'll be doing next time. Okay, so we're gonna be use the sine and the sine to find a formula that will actually model this kind of behavior. So now I give you the Ferris wheel, I tell you, okay, give me a formula for it. And that's really what we will be doing next time. All right, I think your quiz is right now on Brightspace. Let me remind you how we do it. I'll share the screen one more time, and then it shouldn't take a lot of time, but so let's me how to do it. So give me 1 second. Okay, that's your page. You go to the content area. And usually you go down, quizzes and exams. You click on it. You will have quiz 2. You guys have plenty of time. And the main thing is you have to show your work. If I don't see the work, I don't give credit. Is that clear? I did that when I graded you last time. I want to see the work. So this is the quiz 2. You click on it and you get the quiz in front of you. Okay. And when I say exact value, I mean exactly what we've been talking about in class. Okay, good luck. If you have any questions, put them on chat privately. And right here, I'm gonna give theta, cosine theta, sine theta. I will give you the basic values in case you need them. All right, get going.